both ways. Okay? So for instance, let's take something like, pick a problem, let's say, ammonium chlorate. Okay? Let's say ammonium chlorate. Okay? Yes? Yes? Okay. So let's do the percent composition. Can you do that yet, or are you okay with that? How do you do percent composition? Anybody remember? No? It's the total mass of the element over the total mass of the particle. Okay? Total mass of the element over total mass of the particle. So what's the total mass of ammonium chlorate? Anybody know? Can anybody do that? What is nitrogen? 14. Hydrogen? 1, so that's 4. Chlorine?
35.
We'll say 35.4, and only because it's too much to round. I know I've said 35 before, but 35.4, that's one of the few elements that are common that it's good to round, good not to round, okay? Make it in tens place, yes? Okay, and then 3 oxygens would be what? 48. So we have 0.4, what do we have? 14 plus 4 plus 35.4 plus 48. What do we got? 101.4? Yes? Okay, so what is 14 divided by 101.4? And that will be nitrogen. So what's the percent of nitrogen? Yes?
So 0.138. So like 13%.
0.138. So we'll say 13.8%. Yes? Maintaining 3 or 4 significant figures is important here, okay? Especially when you do the moles, and I'll explain. So, what is hydrogen going to be? You see that it's not much. There's not much hydrogen there. What would hydrogen be? What is 4? So it's going to be less than 4%. So what do we got? 3.9%. 3.9%. And what about chlorine? 34.9%. And what about oxygen? It'll be most oxygen. 47.3. Okay, this is actually a fairly challenging problem. Easy for percent composition, but if this were empirical formula, it would be challenging. Yes? So if you can do this empirical formula, you're doing all right. So let's do it. So let's say that I have a substance, we'll say it's a salt, okay? I have a salt that has the following elemental composition, percent composition. It is 13% nitrogen, 3.9% hydrogen, 34.9% chlorine, and 47.3% oxygen. And I want you to write the empirical formula. What's the first thing you do given this? You have to agree on what? Because you're going to be given percent composition in order to write the empirical formula. So what's the first thing you're going to agree on? What amounts of this substance will you have available? A 100 grams, correct? So think, if you're given percentages, think you have 100 grams. So how many grams of nitrogen will you have? 13.8. 13.8 grams. So I have 13.8 grams of nitrogen. okay? Divide by 14, because you got it. The first thing you do after you agree on the 100 grams is you convert everything to moles. So what is 13.8 divided by 14? I want 4 decimal places. 0.9857. 4 significant figures with moles. Okay? Is that all right? All right. How many moles of hydrogen do I have? That should be an easy one. How many moles of hydrogen do I have? 3.9. You don't want to round that to 4. You want to keep it as 3.9, okay? You want to keep as many significant figures as you can. Yes, it's 3.9. 3.900 is really what you want, but the 00 doesn't matter. But you don't want to get rid of significant figures, okay? Randy, you all right with that? Okay. So it would be 3.9 hydrogen grams divided by 1 equals 3.9 moles. This is moles, okay? What about chlorine? What about chlorine? So it'll be 34.9 divided by 35.4. What is that going to equal?
0.9858.
0.9858. Is that what you said, Brandon? Yeah, good, excellent. And what about oxygen? I have 47. Can you see that up there? Is that coming up? 47.3 divided by 16 equals what?
0.9854.
Point.
Oh, wait, no, mind.
2 point what?
2.956.
2.956. Okay, good. So far, so good? Yes? You know that these are moles, right? Ava, you all right with this? You sure? Is that like, yes, I'm all right with this, leave me alone, or yes, I'm all right with this, it's cool? Okay, good. Okay. So now we want to put down our ratios. You have 4 elements. How many ratios are you going to want? 3. Yeah, I know, they say 4 because you do it with itself, but 3 ratios. Minimum of 3. If you have 4, minimum of 3. Clear? Yes? All right, so it'll be, the largest will be the king. All right, so it's going to be hydrogen over, what's this? I didn't put it down. Let's get rid of this, and let's say this is nitrogen, this is hydrogen, this is chlorine, and that's oxygen. Okay? You just got to keep your wits about you. Make sure everything is labeled. So hydrogen over oxygen, right? That'll be 3.9 divided by 2.956. Right? You all right with that? Just hang in there. This will happen. Okay? And then you have hydrogen over what? Chlorine. It's going to be 3.9 over 0.9858. And then hydrogen over nitrogen, 3.9 over 0.9858. What did I say? 3? What did I say? 3? Let's see, you can make more than 3, can't you? You can make more than 3, right? You can use these and you could be fine, but let's make more. Let's make as many as we can, okay? We'll really sell this, yes? So what other ratios can you make? You have this over this, over this, over this. Then what else can you do? What else can you do? You could say oxygen over chlorine, right? Isn't that going to be the same as oxygen over nitrogen, oxygen over chlorine? Same, right? Same? Yes? Okay. So you could also say oxygen over chlorine and oxygen over nitrogen, right? That's going to be 2.956 over 0.9858 and 2.956 over 0.9857. All right, I think we're done. Yes? Now let's do the ratios. We made 6 ratios. That's pretty good, don't you think? More than enough. We made 5 ratios. Yes? I said 3. You can get away with 3. That would be fine. The more the merrier. Yes? Okay? So what we did was the largest over the next largest, the next largest, the next largest. Yes? And then we did the next largest over the next largest, the next largest. Yes? Clear? And then this over this is going to be 1 to 1, so it doesn't matter anyway, right? You can just double check your data if there's a question. Yes? Okay? So let's put this in any order you want. We'll put it in any order you want. We'll put it in nitrogen, we'll put it in oxygen, chlorine, and we'll put it in, what's left over? What am I missing? Hydrogen? Okay. We'll put it in, because the empirical formula doesn't presuppose you know necessarily what the chemical is yet. Correct? You understand that? Because you're just doing it in order. We're doing it as if you have no idea that it's ammonium chlorate. You have no idea. So you just put the 4 elements down and that's it. Clear? Yes? Okay. So what is the ratio between hydrogen and oxygen? Let's do this. What's 3.9 divided by 2.956? Anybody? What is it? Let's go, guys. Come on. 1.3. 1.31. What?
6.956.
Sorry. 1.31, right? Is that what you get? Now, how can you use 1.31? Does that make any sense to you? If you get 1.5 to 1, what would you multiply that by? You multiply it by 2 over 2, and that'll be 3 to 2, right? Do you understand that? You get that? If you have 1.3 over 1, what would you multiply that by to get the nearest whole number ratio? You can do it. You can do it. It would be what? What over what? 3 over 3, right? What's 3 times 1.31? Go ahead. What is it? You have a calculator, Raina? This is my zombie class.
3.9.
Yeah, so it would be 3.93, which is 4. That's fine. 4. 4 to 1. 4 to what? 4 to 1? What would it be? 4 to what? 4 to what? No, not 4 to 1. You're multiplying it by 3 over 3. So it'll be 4 over 3. 4 over 3. So this is 4 over 3. You get that? What's wrong?
4 over 3.
What did I do? 4 over 3. Thank you. Ellen, nice assist. Excellent. Is that coming up on the screen? Is it? Let me see. All right, so what I'll do is I'll move that over a little bit like that. Now it's on. Okay. So, what is 3.9 divided by 0.98?
3.95.
So that's going to be what? That's close enough to round it to what? 4 to what?
4 to 1.
4 to 1, Randy, you can do this. 4 to 1. And then 3.9 over 0.9858 is what? What's that going to be? Same thing, right? 4 over 1. What is 2.956 divided by 0.9858? That's going to be what? 3 to 1, right? So this will be 3 to 1, and this will be what? Same? Okay? So now let's put our ratios in, okay? So what can we do? What's nitrogen to oxygen? What's nitrogen to oxygen? Do we have it? Right here. 3 to 1, right? 3 nitrogens to 1 oxygen. Is that right? 3 oxygens, right? So this will be 3 to 1. Good. What's next? What about hydrogen to oxygen? Hydrogen to oxygen. 3 oxygens, 4 hydrogens. Is that right? Yes? Okay, good. What about hydrogen to chlorine? 4 to 1, right? 4 hydrogen to 1 chlorine? Isn't that what we have? Isn't that already there? Excellent. What about hydrogen to nitrogen? 4 to 1, right? What's left? Oxygen to chlorine. 3 to 1, yes? Yes? And then oxygen to nitrogen is 3 to 1. So it's cool, right? So that is the answer. Right? You understand that? Now, if I gave you a test and I said to you, what's the empirical formula given these percentages of these elements? And you told me that this was it. Yes? I would give you full credit. I'd give you full credit. Because the next question would be, it would be 2 separate questions. What is the empirical formula given these percentages? And that's what you'd say. Yes? And that's fine. Full credit. The next question would be, what is the true arrangement of those elements? Separate question. Right? So do you see, do things just stick out at you now that you know a little chemistry? Doesn't the nitrate just jump out at you? So it's nitrate, -1, right? So you know that, right? And what's NH4? Isn't that ammonium? Right? So it makes sense that the true formula would be what? Sorry, not NCl, sorry. Chlorates, sorry. It would be NH4ClO3. Does that make sense to you now? A little bit more sense? Yes or no? Now, I might not do that problem when we do chapter 10. Yes? But Ava, I know you struggle with chapter 10. And that's okay. I mean no disrespect. Yes? But I'm not asking you to write an essay on empirical formula. But don't you strangely follow this in a way that you didn't follow it earlier in the year? You do, don't you? Do you know why? Because of this. And this is what the final is all about. Are you ready, Dennis? Why does Ava strangely follow this more than she did in chapter 10, where you have this and then you have this? And she can strangely follow it. How many people are also in the same boat where it strangely makes more sense than it did back in December? Yeah. And this is the reason. This is the reason. And this is what the final is all about. You're starting to make connections among many concepts. And the final exam can't be overwhelming. It has to be in a way where you can make the connections that you didn't have time to make earlier in the year. Now, that's why the preparation for the final exam is so important. If you didn't do a lot of work, or even if you did do a lot of work, you want to start making those connections. And if you did a lot of work, those connections should be easy to make, right, Ellen? Aren't you strangely making these connections day by day, almost multiplicatively? Aren't they? Aren't they multiplying day by day? Yeah. And that's what the final exam is all about. Musab, aren't you making these amazing connections? Because you are actually one of my best students. So you are making these connections, and it's overwhelming you. You look so tired and overwhelmed from today's activity that you've made so many connections. He's exhausted, and he should be. He always comes in here, he stays up all night doing homework, and he's such a good student. But did you understand the point in the bill? All right, we're off.